Welcome back. Today, we're diving into a piece of equipment that's absolutely essential, but, often goes completely unnoticed, the transfer pump. It might not look like much, but trust me, this hidden workhorse is the key to keeping massive industrial operations running. So let's get right into what makes this thing so important.
Seriously, just think about that for a second. You've got these enormous tanks, super complex networks of pipes and fluids that have to be in the right place at the right time. You can't just, tip a giant tank over. This is a huge challenge that needs a reliable, powerful, and most of all, safe solution.
And here's that solution, the transfer pump. At its very core, it does exactly what it sounds like. It transfers fluids. Simple, right? Whether it's pushing crude oil from a storage tank into a massive pipeline or moving water into a treatment system, this is the machine that gets the job done.
But its mission is way more varied than you might think. It's not just about getting liquid from point A to point B. Sometimes the whole point is to crank up the system pressure for better atomization. That's just a fancy way of saying turning a liquid into a fine spray, which makes a burner way more efficient. Other times it's used for really critical maintenance stuff, like flushing out all the lines during a shutdown. It's basically the Swiss Army knife of fluid dynamics.
Okay, so now that we know what it does, we have got to talk about the single most important part of how it's used, and that is, without a doubt, safety. And no, that is not an exaggeration. Before you even think about what type of pump you need or what's going to power it, making sure the setup is safe is job number one. Everything else is a distant second.
And that's a fair question. It's just moving liquid, right? How dangerous can it possibly be? Well, the danger isn't really in what the pump itself does, it's about the environment it's working in. It all comes down to pressure.
300 psi. That's the typical pressure a transfer pump is rated for. And yeah, that might sound like a lot, but in the world of industrial pipelines, which can run at way, way higher pressures, it's actually pretty low. If you hook this pump up to a high-pressure line without the right protection, well, you've got a recipe for disaster. So here are the 3 non-negotiable rules you have to follow. First, you install a check valve. Think of it like a one-way door. It lets fluid out but stops that dangerous high pressure from the main line from flowing backward and destroying the pump. Second, you need overpressure protection, usually a bypass valve, which gives any excess pressure a safe place to go. And third, you have to put the pump in a safe spot, which really depends on its power source and if you're in a hazardous zone.
All right, with safety locked down, we can finally move on to the next big decision. Now it's time to pick the right tool for the specific job you're trying to do.
Think of it like a mechanic picking the perfect wrench. There are 5 main types of transfer pumps, and yeah, they all move fluid, but they do it in really different ways, each with their own pros and cons. The choice you make here is going to have a huge impact on your efficiency, your maintenance schedule, and of course, your budget.
Let's just break down the options real quick. If you're moving clean fluid and you want something small and easy to take care of, the gear pump is your best friend. But what if your fluid has gunk or debris in it? Then you're going to need a screw pump. Centrifugal pumps are absolute workhorses, but they get a little picky if the fluid's viscosity changes. For a simple, low-pressure job where you don't want to spend a lot, the diaphragm pump is perfect. And for the really big, heavy-duty, high-volume stuff, you bring in the big gun, the triplex pump.
Okay, so you've made it safe, and you've picked the right pump for the job. Now, for the final piece of the puzzle. How are you going to power this thing?
So your 2 most common choices are diesel and electric. And it's a classic trade-off, right? A diesel engine gives you total freedom. You can run it anywhere, no power grid needed. The catch? Constant maintenance. An electric motor, on the other hand, is super quiet and low maintenance, but you're chained to an electrical outlet. And here's the crucial part. Electric motors can be made explosion-proof, making them the only real choice for hazardous zones where a diesel engine is just too risky.
And there's actually a third option you should know about, air-driven pumps. These are incredibly safe and need almost no maintenance, which sounds great. The only catch? They just don't have a lot of muscle. So your choice really comes down to balancing autonomy, safety, maintenance, and the raw power you actually need.
So we've covered a lot of ground here. The mission, the safety rules, the different technologies, and the power sources. Let's pull it all together into one simple final checklist.
After all of this, what are the things you absolutely have to remember? If you're ever standing there needing to pick one of these machines, what are the questions that have to pop into your head?
Here it is, your 4-point plan. 1. Define the mission. What are you pumping, and is it clean? 2, and this is the big one, prioritize safety. Get those valves installed. 3, select the right tech. Pick the pump that fits the job and the budget. And finally, 4, match the power source to your location and what your team can handle. It's a pretty straightforward process that leads to a safe and effective result every single time.
You know, transfer pumps are a perfect example of technology that's so fundamental it just becomes invisible. They're just one of these countless, brilliant little machines working hard behind the scenes. It really makes you wonder, what other hidden workhorses are out there, quietly keeping our world moving? Something to think about. Thanks for joining me.